Taj Mahal, our monument of pride at Agra. The focus and concern has shifted from freezing its beauty and splendor through a lens or a brush to the critical debates of its becoming pale and corroded. This is but one isolated example of a problem of global proportions. Let us move a few hundred kilometers away to Delhi, the capital of India. This is the fourth most polluted city in the world. Perhaps the situation is worse in the top three: Mexico, Rio de Janeiro, and Tokyo. Air pollution indicators far exceed the national environmental standards. Just stay here for a few minutes and you will feel an irritation in your eyes, and smoke blurs the vision.
See, it has been seen in the recent WHO report, which was published in 1992, that 1 out of 8 children, they suffer from some kind of respiratory problem, such as asthma, chronic bronchitis, and upper respiratory symptoms. Recently, a few studies have been published from South California, where they have correlated the respiratory symptoms in various children and their lung function with reference to the levels of these pollutants. And this 10 years, the study which was followed up over 10 years period has shown a good correlation between the levels of these pollutants and the respiratory ailments in these children. It is very difficult to fractionate the effect of a single pollutant because all of them are there simultaneously. So, but what we can say that there is definitely a synergistic effect. But in some cases, a particular pollutant has been associated with a particular problem. So these studies are there.
Not only is air pollution injurious to the health of children, even adults and especially senior citizens suffer from its hazards. Shri Prithvi Singh remembers vividly how this city was nearly 50 years ago.
आज मैं इसी गांव का निवासी हूँ, मेरा जन्म यहीं का है। मेरे 60 साल की उम्र से मुझे दिल्ली की काफ़ी अच्छी तरह याद है। मैं यहाँ पर ही रहा, यहीं पढ़ा और मैंने इस दिल्ली को बहुत हरा भरा देखा है। बड़ी खूबसूरत दिल्ली देखी है मैंने। अगर 60 साल पहले की दिल्ली बताई जाए तो प्रदूषण नाम की चीज़ बिल्कुल नहीं थी यहाँ पर। बहुत विदेशी लोग यहाँ पर देखने के लिए बड़ी खुशी से आते थे और आज का तो ये हालत है कि प्रदूषण की वजह से परेशानी ज़्यादा है। सभी दरख्त जो हैं वो कम हो गए हैं।
What we are doing to the environment and to the balance in nature is of grave concern, and we will explore this aspect in detail in the first part of our program, Slow Poisoning. Imagine this basketball to be the planet Earth. Then, the atmosphere is thinner than this sheet of newspaper. Without its atmosphere, the Earth would be as lifeless as the moon and frozen, instead of averaging about 15 degrees Celsius. Our present-day lower atmosphere is a mixture of gases, chiefly 78% nitrogen and 21% oxygen. The remaining roughly 1% includes gases such as carbon dioxide and some traces of other gases, together with a variable amount of water vapor whose concentration may range from a negligibly small value in a desert to about 5% in a steamy forest. The composition of air has not changed fundamentally over the last 600 million years. So when did pollution begin to become a problem? Presumably 2 centuries ago, in the early 1800s, after the first coal-powered industrial revolution. The rapid growth of global population, shifts in lifestyle, large-scale industrial production, and automobile exhaust are relatively new contributors. Finding their way into the air, a number of contaminants and industrial discharges aggravate the situation. The smoking stacks, acrid exhaust fumes, and industrial haze once covering only urban towns and cities have now spread to blanket entire regions. There is no longer any room for doubt about the harmful consequences. Statues and buildings have been blackened with soot from unburned fuel, consisting mostly of carbon particles and industrial ashes. When is air clean and when is it polluted? And does natural mean clean? These questions are difficult to answer. Technically, air is never perfectly clean, but is considered polluted when the presence of one or more undesirable contaminants in the atmosphere alter the chemical or physical or biological quality of air. We consider only those impurities as air pollutants which are present in sufficient concentration to cause some measurable adverse effects on either living organisms or on materials, and even if these interfere with the normal enjoyment of life and nature. The source of airborne wastes are so many and so varied that pollution of the atmosphere is a fait accompli. Much of this still happens from uncontrollable natural processes. Like this eruption of a volcano. This volcano is not only devastating in its vicinity, but also releases massive discharges of dust, ashes, and sulfurous gases high into the atmosphere, affecting it for a long period of time. Dust and sand are light enough to be carried by wind in storms like this one. Raging forest fires release quantities of noxious gases and odors in a few hours that the slower, natural processes of decay of surface debris would have taken many years. And these are the pictures of rising pitch-black smoke over Kuwait City during the Iraq-America Gulf War in 1991. Smoke, fumes, and aerosols are extremely fine particles. Their sizes are less than a micrometer, 1,000 times smaller than a grain of sand. Larger solid particles temporarily suspended in air are commonly called dust. Solid particles like this coal dust in a mine tunnel are less than 10 micrometers in size. When they become airborne, they stay there suspended for a long time before settling to the ground. They are called suspended particulate matter, or just SPM, or PM10 by workers in air pollution. Power stations and industries release as much as up to 75% of SPM into the atmosphere. Some are as small as just 2.5 micrometers. And there is increasing scientific and medical evidence that exposure to these ultra-fine particulate matter causes and aggravates respiratory diseases and can even cause cancer. In recent years, the atmosphere's burden of pollutants has increased dramatically. The burning of fuels such as coal, petrol, diesel, LPG and so on is still the main source of civilized air pollution because the steps to remove the byproducts that result from their combustion are inadequate. If carbon dioxide and water vapor were the only products, the burning of fossil fuels would not pollute the air. But the circumstances are not so ideal. The combustion produces other products, including small amounts of chemicals like sulfur and nitrogen. More often than not, incomplete combustion of coal, diesel and petrol in inefficient engines produces carbon monoxide instead of carbon dioxide. Although carbon monoxide is quickly removed from the atmosphere, it can nevertheless be highly toxic. Normally, oxygen atoms attach themselves to hemoglobin in the blood, forming oxyhemoglobin, allowing the transport of oxygen throughout the body. Carbon monoxide can, very similarly, combine with hemoglobin. And when this happens, it effectively shuts out the possibility of oxygen attaching to hemoglobin. Carbon monoxide causes poisoning symptoms depending on how much of the blood's hemoglobin it attaches to. When this happens, people may suffer from headache, dizziness, heart and lung problems, and in severe cases, even death. The addition of pollutants to the atmosphere can have a significant global impact, as in the now infamous ozone hole case. The outer reaches of the atmosphere, near the stratopause, contains a layer of ozone. The thickness of the layer varies from 10 kilometers to as high as 50 kilometers. Ozone splits into oxygen when hit by ultraviolet radiation. The energy of the life-damaging UV radiation is thus converted into harmless heat. Oxygen reconverts into ozone, thereby maintaining the ozone levels. Hence, the ozone layer functions as a global shield from the solar ultraviolet radiation. But this ozone screen is under attack. Scientists believe chemicals, particularly widely used chlorofluorocarbons or CFCs, have thinned the protective ozone around the globe. This damage is now taken most seriously. When CFCs were first introduced in 1930s, it was called a miracle gas because of its non-poisonous, non-inflammable and immensely stable nature. Foams and aerosol sprays used CFCs as propellants. CFCs are also used in making foams for mattresses and curtains and packaging materials for insulation. When ultraviolet radiations strike them, a CFC molecule releases a chlorine atom. Then the free chlorine atom steals one oxygen atom from triatomic ozone, thus destroying it and forming chlorine monoxide and diatomic oxygen molecule. But the oxygen atom in chlorine monoxide is attracted to the free oxygen atom and breaks away to form an ordinary oxygen molecule. The chlorine atom is left intact to continue the catalytic damage of ozone for almost 100 years. Every % reduction of this protective ozone screen could cause anything up to a 3% increase in the amount of ultraviolet radiations reaching the surface of the Earth, and this can cause a great deal of damage. Since 1980, we've experienced the 13 hottest years on record in just 20 years. Is our world getting warmer? Yes, scientists believe that global warming is real. The temperature on Earth is already 1 degree Celsius higher than the last century. There may be many causes for this variation in global temperature, but some scientists believe that this intensification of the greenhouse effect is one of the reasons. The incoming solar radiant energy strikes Earth's surface, causing it to emit long waves of infrared radiations like a giant radiator. Because of the atmosphere, however, only a fraction of that heat makes it directly into space. The rest is trapped in the lower atmosphere and absorbed by the gases. This entire process of temporary retention of heat is what is called greenhouse effect. And because of this effect, the global climate is much warmer than it would be otherwise. And evidence suggests that there is a discernible human influence on global climate. Scientists on Hawaii's Mauna Loa have recorded a steady increase in the concentration of carbon dioxide for 32 years. And it is now about 30% higher than it was before the Industrial Revolution. With increased heating, more water evaporates from oceans, lakes and soils. Because a warmer atmosphere can hold more water vapor, this creates a power feedback loop. The hotter it gets, the higher the water vapor content of air, and thus greater the warming. And we have little direct control over the volume of water in the atmosphere. Adding to the misery, we produce other greenhouse gases too, which intensify the effect. generated by bacteria in paddy fields, decomposing garbage, guts of ruminant cattle ranching, and incomplete burning. Methane is the principal gaseous ingredient of a wide array of volatile organic compounds. Methane persists in the atmosphere for nearly a decade and absorbs 20 to 30 times more heat than carbon dioxide. The potency of methane has contributed an estimated 15 to 20% to the global warming in modern times. Nitrous oxide, better known as laughing gas, plays a somber role in the atmosphere. Produced by microbes in soil, its increase comes from nitrogen fertilizers in agriculture, and slash and burn farming, as well as by fossil fuel emissions in industries. Although nitrous oxide is roughly 200 times as heat absorbent, it adds about 5% to the man-made burden of the atmosphere warming. If this trend of increasing concentration of greenhouse gases in the atmosphere continues, there would be warming of atmosphere. We appear to have opened up a Pandora's box. Let us look up the recipe of doom that we appear to have created. The Industrial Revolution, in a way, heralded the beginning. For the first time, large amounts of pollutants started getting into the atmosphere. As we progressed, we continued to add more and more to this problem. Automobiles, larger and faster transport systems, all these only ended up in adding newer materials into the atmosphere. Our understanding of the harmful effects of our actions simply doesn't appear to be keeping pace. Pollutants can have a range of effects on the human body, ranging from a simple urge to cough or watering of the eyes to asthma, asphyxiation, and cancer. Plants and animals also have to pay for our folly. Large-scale damage in the form of acid rain, ozone hole, and greenhouse warming of the earth can also occur. It is almost as if we are sitting on a time bomb waiting for us to make just that wrong move. The Bhopal gas tragedy is a grim reminder we dare not forget. The logical question to ask would be, so what can we do about it? Rolling back, of course, is impossible. Lessening our greed and increasing our awareness and sensitivity could help. We will look at some such measures in the next part. Till then, goodbye and take care.